Between September 9 and 12, 2025, an unusual but highly significant experiment unfolded at Germany's Grafenwehr training area. Soldiers from the Joint Multinational Training Group, Ukraine, working with the US Army's Combat Capabilities Development Command, conducted a series of live-fire trials involving a Skydio X10 Delta drone modified to drop fragmentation grenades. Over the course of several days, the small quadcopter released 117 live M67 grenades using a purpose-built release mechanism designed specifically for the task. While the sight of a compact drone carrying out what amounted to miniature precision strike missions may have seemed unconventional, the implications for modern warfare are profound. The test was not just a technological experiment but a deliberate exploration of how small unmanned platforms can extend the reach, survivability, and lethality of infantry units operating at the sharpest end of combat. The Skydio X10 Delta is, at its core, a reconnaissance-focused platform, designed to provide small units with reliable aerial surveillance in environments where situational awareness is critical. Yet, during these trials, engineers equipped it with a lightweight release system referred to as the second-generation audible dropper. Earlier prototypes of similar devices had demonstrated that drones could indeed release hand grenades, but those efforts lacked the consistency and safety required for real-world combat. The new system sought to refine the concept, allowing the drone to carry and release grenades with a degree of control and accuracy that would make the capability tactically viable. By stressing the system with live munitions under realistic conditions, the development team aimed to uncover weaknesses, make rapid adjustments, and move closer to a standard that could be trusted in the field. The M67 fragmentation grenade, long a staple of US and Allied infantry forces, is simple but effective. Compact, reliable, and lethal within a radius of several meters, it has traditionally been deployed by the strength of a soldier's arm. That limitation means the effective employment range of the weapon is measured in tens of meters at best. By mounting the grenade on a small unmanned platform, however, its reach expands dramatically. A drone can carry the munition hundreds of meters away, deliver it from altitude, and drop it precisely on target. This changes the geometry of small unit combat. A squad can now influence a fight at standoff distances without exposing itself to immediate retaliation, suppressing enemy positions or harassing supply routes from relative safety. In dense urban terrain, drones can bypass walls, rooftops, or fortified alleys, creating angles of attack impossible for ground troops to achieve without significant risk. This tactical transformation is one of the reasons the trials attracted such close attention. The Army's goal is not to replicate the heavy ordnance carried by larger strike drones but to give frontline troops a tool that bridges the gap between close combat and indirect fire support. In many ways, the grenade-dropping quadcopter represents a marriage of simplicity and innovation, pairing one of the most ubiquitous infantry weapons with a platform that has become synonymous with 21st-century warfare. For soldiers tasked with operating in contested areas, the ability to apply precise firepower without stepping into the open could make a decisive difference in survivability. The trials themselves were conducted with an emphasis on realism. Rather than treating the event as a mere demonstration, the team deliberately pushed the system until it failed, then implemented fixes in real time. Adjustments were made to stabilize the drone's flight under load, improve the reliability of the drop mechanism, and fine-tune the timing of releases. Engineers monitored performance closely to ensure that every adjustment preserved the integrity of safety protocols, even as live grenades detonated on target. This iterative, hands-on approach reflects a broader cultural shift in Army innovation, the move from slow, bureaucratic acquisition processes toward rapid prototyping, soldier feedback, and real-time engineering. The emphasis is not on delivering a perfect product out of the gate but on iterating quickly until a workable, combat-ready solution emerges. The broader operational context also highlights why this experiment matters. The ongoing war in Ukraine has demonstrated the transformative role of small drones in modern combat. Both Ukrainian and Russian forces have used commercially available quadcopters to drop explosives on enemy troops, armored vehicles, and defensive positions. These improvised systems, while crude, have proved devastating in effect and difficult to counter. For the US Army, the Grafenwehr trials are not about reinventing the wheel but about moving beyond improvisation. Instead of leaving soldiers to attach makeshift payloads to commercial drones in the field, the goal is to develop standardized, safe, and reliable systems that can be integrated into tactical doctrine. By doing so, the Army can provide troops with a capability that is both effective and predictable, while reducing the risks inherent in ad hoc battlefield innovation. Yet the move to weaponize small drones also raises questions about escalation, doctrine, and ethics. A platform once associated with reconnaissance and intelligence now takes on a direct combat role, blurring the line between surveillance assets and offensive weapons. This shift will force commanders to reconsider how such tools fit within the broader framework of rules of engagement and proportionality. The ease with which small drones can deliver lethal effects also means adversaries may respond with greater urgency to counter them, further complicating battlefield dynamics. Nevertheless, the Army appears committed to exploring this avenue, reasoning that if adversaries are already exploiting such tactics, it cannot afford to lag behind. From a purely practical standpoint, the results of the Grafenwehr experiment were encouraging. Operators reported that accuracy improved as adjustments were made, with the system eventually delivering predictable fall patterns that suggested it could be refined into a dependable tool. The compact nature of the dropper mechanism allowed it to fit within the drone's payload bay without sacrificing stability, while iterative modifications boosted reliability. These outcomes suggest that with further development, the technology could transition from prototype to field-ready capability, giving infantry units an entirely new way to apply pressure in combat. At the same time, the trial underscores the importance of multinational training and cooperation. The JMTG-U initiative, designed to support Ukraine's defense reforms, doubles as a testbed for tactics and technologies inspired by lessons from the Ukrainian battlefield. By experimenting in Germany, the US Army can study those lessons in a controlled environment, assess what works, and develop solutions that can be scaled across its own force. This collaborative approach ensures that emerging battlefield realities do not remain isolated to one conflict but instead inform the evolution of military doctrine more broadly. In the years ahead, the integration of small weaponized drones into US Army formations may remain a subject of debate. Concerns over safety, escalation, and doctrinal clarity will persist, and technological refinement is still necessary before such systems can be deployed at scale. However, the Grafenwehr trials represent a clear marker on that path, an acknowledgement that the nature of infantry combat is changing and that even the most familiar weapons, like the humble hand grenade, can be reimagined through the lens of unmanned technology. For soldiers on the ground, the ability to project lethal force at a distance using inexpensive, adaptable platforms could become one of the most significant tactical shifts of the coming decade. Ultimately, the September 2025 exercise was more than an experiment in hardware. It was a statement about adaptation, resilience, and the willingness of a modern army to learn from ongoing conflicts rather than wait for future wars to deliver their lessons. By deliberately testing, breaking, and refining a system that combines the old with the new, the Army demonstrated that innovation does not always require futuristic technology. Sometimes it is about seeing existing tools in a new light. As unmanned systems proliferate and the battlefield continues to evolve, such willingness to innovate at the tactical level may prove just as decisive as any high-end strategic system.